We talked about what limits are in calculus and how they're related to the math that we've gone over so far. I'm going to show you one example of how to solve solve for limits using graphs. Okay, so the first thing we're going to do, since we don't graph by hand anymore, well, maybe you do, but is you're going to go to Google. We're already on there, but I'll just type it in for fun here, and you're going to look up graphing calculators. Okay, then hit enter, and there's a ton that you can pick from, which I'm sure they're all great. I tend to use this first one, this Desmos, or there's another really good one called GeoGebra that you can use. They're all pretty much the same, very, very user-friendly, probably more user-friendly than your calculator, actually. I'm just going to show you on the screencast since I don't want to do a recording of my calculator. So if you need help with your calculator, though, do let me know. So I'm going to click this first one, Desmos Graphing Calculator, and it brings you to a screen like this. Okay, you can create an account, you can sign in. You don't really have to do that. If you want, you can just start plugging away. So what I'm going to do first is type in a function. I'm going to type in the first function from the example that's in the book. So it's f of x equals x to the third minus 1. Now for this exponent right here, you're just going to use the caret symbol, which is shift 6. If you need help with that, let me know. And then x minus 1 in parentheses, and then I'm just going to hit enter, and then it shows the graph right here. Now, hopefully you remember from pre-calculus or from your previous math classes that you can't actually input 1 on the bottom here. Okay, because if you put input 1 in here, then you'd be dividing by 0. The function would be undefined at 0, so because of that, there's no output if you input 1. However, with calculus, you can use the limit to figure out what it could possibly be if you could actually get to the 1. Okay, so what we're going to do is, based on the first example in the book, we're going to find the limit of this f of x right here as x gets closer to 1. Closer and closer to 1. Infinitesimally closer, but never reaching. Okay, now technically there should be a hole here. If you zoom in on the graph using the scroll, you can zoom in a little bit here. If you input a 1 here for the x, you'll notice it actually spits out a number. There should be a hole here technically, but that's kind of one of the flaws of this technology. Sometimes calculators don't, show where the holes are. I believe your calculator shows it, but if you zoom in a lot, I'm sure this one does too. But it doesn't matter. Knowing that you can't input 1 just from your previous math classes, you should be able to solve this. So if you input a 1 here and you actually use the graph for the 1, you'll notice the limit would be 3 if there was a hole there. Going from this side and going from this side, they both converge to the number 3 for the output of the function. So the limit here in this case, as x gets closer to 1 of f of x, so the limit of f of x as x gets closer to 1 would be 3. So that's one way to find limits using graphing. Okay, if you have any questions about this, let me know.